All right, guys, welcome to CSCI 45, the final computer science class in Columbus Community College. This class is the assembly language class, and normally it's a projects class, but there's a pandemic going on right now, so the projects are going to be scoped down pretty significantly. So let's talk about some stuff. First of all, I have gained experience with online learning last semester. There are parts that went well and other parts that I just wasn't happy with. And so I've been thinking about what problems there were with online learning and what I could do to fix it. And one of the big problems is that student like engagement, is whether it's what like the YouTube people call it, like when they watch people watching their videos, right? You get this graph of like engagement. Um, I can see that on Canvas, and the engagement in my classes start really strong. And right now, there's a lot of people online and stuff like that. And then over time, like less and less people show up for the live lectures because they tell themselves like, "Oh, well, it's recorded. I can just watch it online." And then they don't watch it online because honestly, who wants to sit there and watch an hour and a half video online? Maybe you'll do it, but a lot of people won't. And then once you stop watching the lectures, you're toast. Like you're not gonna learn the material. And so I was thinking about like, all right, how do we fix that? And so number one thing is that 10% of your grade is now based on talking on Discord during lecture hours. Like if you're on Discord right now and you are saying things, congratulations, you have earned your participation grade for the day. The other way you can get participation grade is by going to the Help Center. Make sure that you have tagged yourself with the CSCI 45 role, and make sure that your username on Discord has your last name in it. That's how we know who you are. If your username is Gummy Bear 420, whatever, like I don't know who the hell you are, right? So on Discord, make sure at least your last name is in your username. Say something during lecture. It's fine. If you can't make lecture, the lecture channel gets locked down outside of lecture hours. So go into the Help Center and ask a question. You will have questions, I guarantee it. In CSI 41, some guy just went on there and went, "Hi." Like, no, don't do that. Don't be that guy. "Hi, I want my participation point." No, 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 no. Ask a question. You're going to have a question. Trust me, you're going to have questions. This is a big topic. There's going to be questions. So just ask a question if you can't make the lecture. Okay. And that's a letter grade. It's an easy letter grade. You will get just show up and participate. And the reason why I'm doing this is again because I want you guys to be interacting with me, and when we're online, there's not that same connection. Like normally people to class and people are clapping. Do you guys remember clapping? We used to clap in class, and um, there's this class especially has a really high energy traditionally because like we're wiring things and building cool projects and sentry guns and things like that. And now it's just like you're just sitting in front of a computer somewhere, right? And so the class participation, thank you for the clap emojis. The class participation is just my way of trying to um, make sure you're talking to each other and talking with me. Feel free to talk during my lectures. I am a professor that encourages people to talk when I'm talking because it doesn't interrupt me. In real life, professors don't like it because if you're talking and somebody else talks over you, then yeah, it's jarring. But now I'll just look over at Discord every so often and yep, um, answer questions and things like that. Okay. So the other way I'm going to encourage you guys participating is the daily quizzes. So after every lecture, this will be recorded, put up on YouTube. I'm using OBS and I'm using YouTube to hold my videos this time because Zoom's kind of garbage. So after the video goes up on YouTube, you have until the start of the next class to take a quiz. There will be a quiz after every class. and the quiz will be on the topics discussed in that class. So just pay attention during lecture, and you should be fine. That's another letter grade. They're not designed to kill you, but if you get it wrong, then that's a sign that you need to study. So the questions on the midterms and finals typically follow they typically track the daily quizzes pretty close. Like that'll give you an idea of what kind of questions I like to ask. So if you get a question wrong on a quiz, then go into the help center and try and figure out why you got it wrong, because you'll probably get it wrong on the midterm and final. So that's an early way of knowing like what I'm expecting you guys to know, and if you don't know something, like to home in on it and fix it. So there's going to be a rhythm in this class that you will need to get used to. The you need to get a whole 20% for just doing participation in quizzes. Time to not do anything else and get enough, yeah. So class rhythm. So daily means Tuesdays and Thursdays, right? So every day go on to lecture. Every day take the daily quiz. Every day talk on Discord. Okay. So just maintain that habit, build that habit of talking to each other, talking with me, taking the quiz, being there for lecture, and hopefully that momentum will sustain you through the semester. Okay. What I really don't want to see is like what happened in my Fresno State class last semester, where I had 90 people in the class, and I would have like one person in lecture, two. Usually, like Pablo and Michael Juarez, who graduated like a year ago, they were there more often than my students. Or like I'd have Nico there, so I'd have like three of my friends there, and then like one Fresno State student, and it was just like really depressing. It's like, where the hell are you guys? Like there's 90 people in this class, and like just nobody's coming to lecture, and so it's like I guess they're kind of doing the work, but based on the questions that I'm getting, like you're not watching the lectures. Okay, so every week there will be one programming assignment, and every week there will be one Zybook. So we are doing Zybooks this semester. Last year I used a free textbook called Dive into Systems, and I wasn't especially happy with it. There were parts of it that I liked. There wasn't enough of it. Basically, a lot of it was just teaching you guys C, and you guys kind of know C already. So Zybooks will. I have issues with the Zybooks also, partly because of the cost, but it teaches a different version of ARM assembly than the one that we're using, and that's why I kind of held off on doing it before. But I've been reading through it. It's well written, and it does explain a lot of the topics in the class pretty well. So every week there will be one reading from the textbook, and all you have to do is read through it. I don't recall there being any programming assignments in it. They kind of are. Like you have to kind of drag and drop code into order and things like that. But it's pretty well written, and it's I think it's a Patterson and Hennessy book, which is like the standard book for this class. Like Patterson and Hennessy has been around since my time, and I have it over here. Nope. But everybody knows it, and so you guys will get to read Patterson and Hennessy, which will make you educated. So one programming assignment per week. This will be mostly in assembly. So we're going to be learning assembly programming this semester. Assembly programming is fun. It's fun. It's fun. A lot of people are scared of assembly. It's fun. It's fun. It's fun. And yeah, some of it might not be. I sort of make up assignments as I go. So I've done things in like Python and stuff before, but mostly assembly. A little bit of C++, maybe. Why do all my friends who are programmers say it's not fun? Because they didn't have me as a professor. That's why I say. Zach's brother, by the way, just got a job at UC Berkeley. He's working as a programmer there. He was my student 2017, around then. And he graduated from here with associates, or I don't know if he bothered getting his associates, but with like an associate's in computer science, tagged into UC Irvine. Graduated from UC Irvine. He was a undergraduate reader, which is like a TA. Usually they don't let undergrads be TAs, but he did well apparently. He was an undergraduate TA. and then he got a job at Berkeley, not as a student, as actually a programmer. So the Berkeley people hired him based on his skills at C++ and optimizing code. And this class will teach you how to optimize code. In previous classes, I have not been really emphasizing code speed because because honestly, I care about correctness more than anything. But in this class, yeah, speed will matter. So, Baba is you, Ada. Baba is you. Are you gonna make Farkle in assembly? I was thinking about it.
If you move the Baba is you, die.
Zach Furia? No, Matthew Muller.
Yeah, you can't put like lava is you.
Lava is you?
Yeah, you can't do that because it'll just die. It'll just move around and then it'll like reset.
Mm-hmm. Yeah. So, can you embed assembly straight into C++ code? You can. There's an ASM directive, but you're getting ahead of ourselves. So yeah, you can embed assembly directly into C++ code, and a lot of games like Doom, for example, they embedded assembly directly into their C++ code. It was probably C code back then. Yeah, it's a thing. And so yeah, assembly has a reputation for being hard and for being annoying, I guess, and it's not really. It's fun. Partly the reason why it's fun in this class is because we're doing what's called ARM assembly. Ada, do you like ARMs? ARM. We're doing ARM assembly. And
is it because the statements are ARM?
It's the name of the company. They made it. Acorn Research something.
Acorn.
Really? Yeah.
Do you think chipmunks or squirrels work there?
No, Acorn Risk Machines. Yeah, that's what it stands for.
So there are chipmunks and squirrels that take risks.
They made a computer for kids called the Acorn. So Acorn Research Machine or Acorn Risk Machines.
There's a book where there's like a giant nut. There's a giant acorn as a monster, and then you know what the superhero did? He got chipmunk. Got chipmunk. Yeah.
Acorn Research and Management. Yeah. So
it's a toothpaste.
That's ARMS. That's the
I played that before.
Switch game. Yeah. Have you considered doing a short exam at the end of every week? No, that's what the daily quiz is. Yeah, what was that, girl? You want to play Skyrim or something?
I beat it in a game. It's like mostly my independent study time, but I'm staying right here.
You're gonna stay right here.
Mm-hmm.
Okay. So yeah, so X86 assembly is really dumb. So X86 is what Intel chips use, and it's really dumb and annoying to write assembly in X86. And so, trust me, you're gonna enjoy ARM32. 32-bit ARM is really nice. It's well designed. It's fun. Yeah.
I was gonna say that why I came in here is because I heard you saying, well, it's because they didn't have me as a professor. Mm-hmm. I remember how you always bring in treats. Like
I used to bring in treats.
Can't do it anymore.
Can't do it anymore. Oh.
You can bring in virtual treats. You can still bring in treats. You can still bring in treats. It's true. You can still bring in treats.
Here, have some virtual vitamin D gummies. Sad. Okay, get it. Nitro. All right. So first things first. All you guys need to get onto the server. So the server is a Raspberry Pi machine that is currently dangling from an Ethernet cable off my bookshelf back there. It's actually around the corner, so you can't see it. But it's literally hanging by its Ethernet cable. It is a Raspberry Pi 4. Raspberry Pi 4s are nice machines, actually. Like, Raspberry Pis have this... if you don't know what a Raspberry Pi is, a Raspberry Pi is a computer. It's a cheap computer. The original Raspberry Pi sold for $25 to $35, somewhere in that range. And they look about this big. Got one right here. Yeah. Thank you for the cupcake. So I've got a Raspberry Pi right here. This was the old fast server. This one is the Pi 3. And so you can see how big it is. And this is a fully fledged computer. It has a SD card sticking out of it.
This is a computer. It has a keyboard right here.
Well, that's where the keyboard connects. Yeah. So it's got an SD card there, and that has all the students' account on it, and all the kids and all that stuff. It's a 32 gig SD card. The CPU is right there, that tiny little thing there, and it's got Ethernet. It's got 4 USB ports. The original one only had 2, which was a problem.
PS5 only has 1.
The PS5 only has 1, and that's a dumb decision.
We have to get that port that you plug into the port.
We had to get a USB hub for it. And then off to the side, you can see it's got HDMI. The Pi 4 has a micro HDMI. It's a different port coming out of it. Let's see. There you go. That's HDMI there. Audio out. Usually audio out's handled by the HDMI, right? Because you plug it into a monitor. Ada, can you turn the light on back there? And Ada, can you turn the light on? Ada, can you turn the light on, please? Dingling is the best form of heat dissipation. Yeah, it's got it. Yeah, my Pi 4 actually has a little fan on it, which is a little weird. Pi 4 actually can generate enough heat that you do kind of need some heat dissipation on it. But the Pi 2 and the Pi 3, yeah, you can just use passive heat cooling. Like these things, like this generates, I think, 2 watts of power consumption. And it's a multi-core computer with a gig of RAM, I believe. And so the, let's see, performance, 10 times, yeah, so this one has 10 times the performance of the original Raspberry Pi 1. And then the Pi 4 is 3 times faster than this one. And so originally when I first started teaching this class, it was Pi 2. And so the Pi 2 was okay. The Pi 3 was nice, and the Pi 4 is actually really nice. It's actually a pretty decent computer. So Pi 2 also didn't have Wi-Fi, which is annoying. So.
Can you also say like the blue, you know, in college, how when you're a major in computer science, like that wired Ethernet like is actually quicker than normal internet.
Ethernet is better than Wi-Fi. That's definitely true.
Do you use Wi-Fi and anything?
Yeah, like everything in this room is hooked up by Ethernet, but everything in the living room is on Wi-Fi. So I've got.
Is that why?
I have a new Wi-Fi hub.
Is that why the computer takes so slow to load?
No, it just takes a while. It's just Windows. Okay, so anyhow, so Raspberry Pis are cheap computers, and they run Linux. This is different from an Arduino. I don't know if you guys have heard of an Arduino before. Ada did a little Arduino stuff for her class projects. She hooked up a Arduino with some servo motors and things like that. And it looks very similar to Raspberry Pi, right? But Arduinos are not real computers. They're devices. And so you have to hook up an Arduino to a PC to program it. This you can hook up a Ethernet, keyboard, mouse, HDMI monitor, and it's a real computer. It's a Linux box. You can just use it as your daily driver if you want. The original Pi was pretty slow, and the Pi 2, like trying to do web browsing on it was like, it's not very fast. But the Pi 3, Pi 4, like I've used this before. It's just like my computer, and it works fine. Just don't expect to play Crisis on it, right? Yeah, and all on 2 watts of power dissipation, right? Like, the fans on my PC draw more than 2 watts, right? I'm pretty sure. So yeah, it comes with Minecraft too. And so these things are really neat. Now, an Arduino is neat too, and they're a little bit cheaper. You can get an Arduino for a little bit less than Raspberry Pi, but honestly, I wouldn't get an Arduino. The only benefit to an Arduino is that it's so simple. Programming it is pretty easy. You basically hook it up to a PC, and there's just 2 functions. One on initialization, one on loop, and it'll just when you plug it in, it runs the thing on initialization, then it runs the code on a loop. And so you don't have to, like this, when you plug it in, it's got a boot, right? But an Arduino, you plug it in, and it immediately just starts. Ada's diorama had fish moving around and stuff like that. Let's see if I can. Facebook might be a little dangerous right now. Let's see if I. Diorama. Let's see. Toasts. Raspberry Pi is not edible.
This time is for raspberry.
Good job, Facebook. Well done.
And don't try eating a breadboard either.
Don't need a breadboard either, my daughter says. Me. There we go.
Here's Ada's final project. It's got 4 LEDs.
Okay, so this is Ada's diorama, and there are 4 LEDs we drilled through the back of a shoebox. And I don't know if you can see it, but they're programmed to get dimmer and brighter, and so they kind of have at different times, and so it simulates like water, like the caustics effect of water. And then there is a
battery.
There's a servo motor that is attached to it. Yeah, that's an Arduino girl. So the Arduino.
No, it's for my school project.
It's not.
I spent this year.
That is not a Raspberry Pi. That's an Arduino. And so there's a servo motor that is moving this fish here on a sine pattern, and Ada adjusted the rate and the size, the amplitude and the frequency of the sine wave, basically. And then it's wired to the Arduino. And so basically you plug it in, and immediately the lights come on, the fish starts moving, and it'll just sit there and do that forever. So
until it runs out of battery.
And until it runs out of battery. Yeah, it's all battery powered too. And so you can look at the back of it here, and
left the battery pack at school.
You left the battery pack at school.
I think so, but I don't even know where it is.
So that's a breadboard, and so a lot of breadboards actually come with a peel-off backing, so you can actually just glue them onto things. And so because breadboards are pretty cheap, and so don't do that in our class if I give you some, because then it'll be sticky. But yeah, it's just stuck to the back of the shoebox, and then the Arduino is plugged in. You can see right here, it's plugged into a battery adapter. Got a couple batteries, and you just turn it on, and power runs from the Arduino to the breadboard. The breadboard has power running to the LEDs and to the servo motor. And so Ada did a lot of this herself. She was a second grader at the time. So if a second grader can do it, you guys can do it. Okay. Yeah. So, but Raspberry Pis are real machines. Like, they're an actual real computer. Arduinos are just toys. They're not toys, but like, they're devices. You can program them, but you can't log into them. Okay. So, I've been having issues with the firewall here. I've got a router, and then I bought another router, and getting both routers to get IP version 6 through it didn't work. And so you can connect on IPv4. If that causes problems, then I'll have to I don't know, move things around up there. I got it working last year where it would work with IP version 6. I've had issues with AT&T not liking me running the server here, and them like black hole routing the response packets. And so what that means is that people can log in, but if they ever try to do anything really quickly, then it generates this giant backlog of response packets that don't arrive, and it fills up the buffer, and it stops. And the buffer is like 56K. And so as long as, and then after 3 minutes, it times out. And so as long as you're not doing more than 56K every 3 minutes, it was fine. I tried it. It seemed to work. I don't know if they're still doing that to me. It's kind of jacked up on AT&T's part. But IPv6 wasn't throttled in that way. So I switched to IPv6 last year. So far, so good. I don't know. Tell me if it doesn't work. But if it doesn't work, then I'll have to redo everything, because I spent like an hour and a half with the firewall configuration, and it just doesn't want to get IPv6 packets through. Yeah, okay. So how do we connect to the server? So if you have a Macintosh, download a secure shell client. On Windows, I use PuTTY. If you've had me before, this should be old hat to you. So when you want to connect to the server, the IP address is going to be rpi.csci4x.com. This is not the normal server. The normal server is Intel based, and for this class, we do ARM. And so you are going to connect to a ARM server. And I've actually looked into not having to host it out of my office. Because like I'll be playing video games and like the video games will slow down. I'm like, what the hell's going on? I'm like, oh, there's a homework assignment due tomorrow. everyone's on my home network here. But Linode, Azure, AWS, none of them offer virtual ARM servers, at least a year ago when I checked. So yeah, you got to connect to this. So the host name is rpi.csci4x.com. When you connect to it, then you have to log in with your username and password, which to begin with is the same thing. So your username / password, they're the same at the beginning, is your last name _ your student ID. If you can't log in, if you added the class, you're probably not on the server. So if you added the class and you can't log in this way, message me and I will create your account. All lowercase. If you have any special characters in your username, let me know, and I'll, like, if you have spaces and apostrophes and hyphens, message me and I'll let you know what your username is. So those aren't allowed in usernames. So yeah, and if when you're typing your password in, it does not echo it to the screen. So it'll, like a lot of students like, it hung, it's not typing any, yeah, it just doesn't echo anything when you're typing your password. So to begin with, you're going to type in your username, which is your last name _ ID. Then you type in your password, which is the same, and then it will take you through the password change process. And when the password change process finishes, it disconnects you, re-log in with your username and your new password, should be good to go. And it'll look like this when you connect. So, extern denied, access denied. Control U, yeah, that's useful. So in baked mode, which is normal mode for typing input, Control U erases the whole line. So if you're typing in your password, you screw it up, Control U erases the whole thing. Email if you can, or just say it here. Yeah, so you can just tell me now. Civido, what is your student ID? Seven, got it. Give me 1 second. Anyone else? Slave. Okay. 0581590. Okay. DeBello got in. Good. Jacobson needs an Hij, Jacob. Sin _07 39481. Garcia _053 0365. Yeah, anybody who needs to add, just message me and I'll add you. I add everybody. You got to type in your new password. All right. Let me create everybody first. Create class CSCI45. All right, you guys exist now. Sudo. Okay. Main, your password is now puppy. Make sure you change it. Or other people, if you want to log in as main really quickly. All right. So AWS does offer ARM. That's cool. They didn't the last time I checked. All right. It's also not cheap to get AWS as well. Let's see if people are on. It looks like people are connecting. That's good. What was the host name again? The host name is rpi.csci4x.com. It is not the usual server that I use. The usual server is x86 based. Yeah, but like ARM is kind of taking over the world. So ARM is I don't know if you guys have heard of ARM before. A lot of people haven't, and it's really fun because everyone knows Intel. Intel makes the CPUs for PCs, right, and for Macs until like a couple months ago, right? So Intel used to kind of rule the roost, and they made the brains of the computers, the CPU of the computers, were all made by Intel, and nobody's really heard of ARM. ARM makes many. Well, they don't actually make anything. ARM itself does not make a single CPU. What they do is they make designs for CPUs and they license them to companies, and those companies then customize the design however they want. They're basically given the blueprints for a CPU, but they're like, you know what? Let's add a little bit more RAM to it, because we're going to be making a Raspberry Pi. Let's make more RAM, whatever. And so ARM doesn't make any CPUs at all, but lots and lots of companies license ARM CPUs, customize them, tweak them, and then fabricate them. And so fabricating is the process of going from a blueprint of a CPU to actually having a physical, chip that you have in your hand. So the chip is inside of the package there. So that's the package. That's actually not the CPU. The CPU is inside of that. It's even smaller than that. And there's companies like TSMC that do fabbing that make the chips. And ARM makes, indirectly, many more CPUs than Intel. Many more CPUs every year. ARM has been making far more CPUs than Intel does, and nobody's heard of them. So what kinds of machines have ARM CPUs in them? Basically every cell phone. So this cell phone, which is some sort of stupid iPhone or something. And honestly, who needs that many cameras? You know what I mean? ARM, Raspberry Pi, ARM. So the can't get into the server. Does walk-up exist? You do. My phone has 3. Yeah, well, it's the iPhone, so it's like a decent camera, I guess. Walk up. You've not logged in yet. Okay, so you need to log it. That's your username and password. Log in as that. Hopefully, you'll log in before somebody else does it for you. This is recorded, but you'll have changed it before. I do not own one. I do not own an iPhone. My dad wanted me to buy him an iPhone for Christmas, and I refused. And so he bought himself an iPhone for Christmas and sent it to me so that I could investigate the LiDAR and the depth sensing camera on them, because I do a lot of motion capture stuff. And so he wanted to see how good the iPhone's motion capture was. And the answer is, it's aight. It's aight. It's not great. I use a LG. I have an LG phone, but yeah, it has LiDAR on it, and it has the back of it has LiDAR, and the front of it has a pretty good depth sensing camera that it generates a 3D mesh of your face pretty accurately. The 3D mesh is actually really accurate, and as you move your eyes around and things like that, it'll actually animate a 3D object on the screen and stuff like that. It's pretty cool. The LiDAR is like, it's not good at tracking. It's not, the mocap on it's like, okay, adequate. Is it possible to see the mesh somewhere? Yeah, I guess. Getting a little bit off topic, but let me boot it up. So yeah, ARM, and Apple is moving to having ARM desktop models. So traditionally, ARM CPUs are low power and low performance, but they have a pretty good price to performance and performance to power ratio. So that's why they've been used in cell phones. You don't want to be drawing 80 watts on a cell phone. You want to be drawing as little power as possible on a cell phone because you're on a battery. The less power you draw, the more battery life you get. And that's why ARM's been winning. Intel does not make Intel makes low power CPUs for laptops, but they don't compete with ARM like at all. ARM's like a 5 times less power, something like that. So, so ARM has been winning, and with all the money they've been coming in, they've actually had the money to design actually reasonably decent desktop CPUs, and so the Apple and their new Macs are going to have ARM based CPUs for their desktop PCs, and they're ditching Intel and going with ARM. So Intel has not been having a good 4 or 5 years at this point. Intel has been struggling. Intel has been struggling. Okay, anyone else able to get in? Was it ever seen ARM and Intel transistor count? Yeah, I mean ARM CPUs typically have a lot less transistors. In general, Intel is designed for performance, and ARM is designed for low power, and those are different trade-offs, right? ARM doesn't have anything near like a Core i9. Okay. Yeah, AMD has been eating a lot of Intel's market share, and now ARM. Now that Apple is getting into it, and there's been ARM-based Windows operating systems before. I think there still is. The original Surface was ARM-based. So, Intel. A friend of mine is a manager, and he went up to Oregon where they do a lot of their stuff, and it's like a dumpster fire, dude. Like, yeah, Intel 10 years ago was completely crushing the market. So with the Sandy Bridge and that whole series of CPUs, they were completely destroying AMD. There was no reason whatsoever to buy AMD other than the fact you wanted to keep them alive so that one day they could challenge Intel's dominance. Like the Core i7 2600 was a fantastic CPU. I had it for 7 years. And when I finally upgraded to Core i9 7900X, there's no performance difference in video games. The Core i7 2600K was a really good CPU, and it made absolutely no difference for gaming. It didn't support NVMe and this other stuff, which did make a big difference. But the CPU performance itself was fine. So you guys on the server? This is a Unix box. If you've never used Unix before, you will need to go through. Let's see if we're struggling here. So this is a 4-core system. It's got the RAMs. Doing all right. Okay. No noticeable lag. All right. So if you have never used Unix before, then you are going to need to go through the Unix tutorial. Not on this one. So let me pull that up for you. So right here is the Unix tutorial that I recommend to people. There, yeah, go through the first 3 chapters. In fact, probably the introduction, tutorial 1, tutorial 2, tutorial 3 you probably should do too. Honestly, just do the whole thing. But you really want to know Unix. If you don't know Unix, you really want to know Unix. Knowing Unix is worth $5,000 pay differential. People that know Unix, programmers that know Unix, typically do much better pay wise than people that don't. And it looks scary. It looks like something out of the 1970s, like war games and things like that. But trust me, it's a joy to program in Unix. It's a lot nicer than Windows in a lot of different ways. And the world runs on Linux, right? Like Linux is a type of Unix. GNU/Linux is a version of Unix, and it runs the world. The internet runs on Linux. It's a phrase, but it's also true. So make sure you go through at least these 3 chapters. All right. So if you've never used it before, here are the basic commands. Go through that tutorial anyway, but here are the basic commands. ls will show you the files and folders in your current directory. ls shows you the files and folders in your current directory. cd changes directories. cd ... goes up a level. cd by itself takes you back to your home directory. cd followed by a folder name, like if I want to go into my music directory, I don't know why I have a music directory, then I can type ls instead of there. You can see it's empty. Oops. Get rid of that. And so if I become somebody, let's walk up, you still can't connect. All right. Become Leah. Ew. What happened here? Walker. What happened to your? Eesh. Eesh. I know what the problem is. Okay, sorry, I'm gonna have to recreate the class. I'm sorry. Everybody log out, please. Everybody, yeah, I know. It was the same problem in the other class, and I fixed it on the one server. I didn't fix it on this one. So everybody log out. You'll get lots of experience changing your password again. I'm gonna purge everybody's account and start over. Did anyone do the homework already? Do I have to redo my vimrc? Yeah. Back it up real fast. You already did it? Well, back it up really fast. I'll give you a second to back up anything. If you need to back up files, there is a program called SCP, Secure Containment Protocol. You copy files to and from. You already forgot your password. Yeah. Okay, so I'm gonna wipe everyone's account and push out everything. That's the easiest way of updating. I had an error in the .cshrc file, and I mirrored it from the other server where there was an error in the .cshrc file. I push out to everybody. I fixed it on the other server. I didn't fix it on this one. Mea culpa. Yeah, SCP. You shouldn't need to use SCP in this class, but if you want, you can log in. I use WinSCP, and when it connects, it just uses your username and password. You can, if you want to copy a file over packages.list, you can just drag it off the server to your PC, and there it is. If you want to copy the motion capture I got from the iPhone, just drag that over there. Okay. Let's look at the motion capture here. So, now you can see this. Is that showing? Do you guys see the mesh on that? Hi. Can you guys see that? Yeah. Exciting. So you can mocap your face pretty accurately, and you can use that to rig animations in game development, which is starting in an hour and a half. So if you guys want to learn game development, IS50 A and IS50 B, I teach every semester now, and so I don't know. I think it's a lot of fun. I don't know if it's fun for you guys, but it's fun for me. You get to play video games, you get to make video games, you get to learn math. What? It's math. And mod games and stuff like that. It's pretty neat. I enjoyed it. So, was it posting canvas? Can't check the class because you're on the wait list. Can't check the class. I don't know what that means. Who needs an ad code? Let me just add you guys right now. That'll be fine. All right, Jeff. I'm just gonna post ad codes randomly. Jeff, there's your ad code. IS50B is just Friday. Yeah, but I would probably show up to the other lectures maybe because you're probably going to be doing some stuff in common with them. Who else needs it? Lave needs it. Okay. Okay. Time to purge the server. You've been looking at the syllabus and noticed you're required to have Bruce Smith Raspberry Pi. Yes. Let's talk about that while this is happening. Delete the group, and then we will now create a class. Okay. Amazon. So this book here. There's a different cover sometimes. I don't see it. This book here is a really, really good book. And it's not expensive. If you get the Kindle edition, it's $13. And that's because it's not a textbook. It's just a book. And Bruce Smith writes really clearly. Here's the other one. ARM32 assembly language. Pretty close to the same book. This one's a little bit better. It's a little bit more advanced. A lot of the chapters are exactly the same. So I would maybe get this one instead, but the other one's sufficient for this class. Really well written book. I went to batter up pancakes and read the book, and then I knew how to program ARM32 assembly. I didn't actually program ARM32 until I started teaching this class, and so I just learned it for this class because I didn't want to teach X86. I didn't want to teach Mips. I didn't want to teach Spark. My assembly class was in 6800 family assembly language, which was old even when I was in college. We used a X Windows system, which is a graphical interface system, kind of like Windows, but older. 3 people were sharing one computer, so you had 3 terminals with Windows and graphics and all that stuff. 3 people sharing one system. There was 4 megahertz. 4 megahertz, not 4 gigahertz, 4 megahertz. And trust me, that was slow even then. It took half an hour to log in on these things, and there weren't enough computers for everybody. And so you would have to sign up for like a 3 hour block to get your homework done. And you'd spend the first half hour of it just waiting for it to log in. It was utter garbage. Utter garbage. And these were machines like from the 1970s. And they're like, it'll be good for you. You'll get to learn the history. No. I learned to hate history. Because, like, if you can't get your homework done, it's like, what do? There's a line of people out the door trying to get in, and you have to sign up days in advance to do your homework. And so, what you do is you come into the lab at 4 o'clock in the morning when nobody's in there. It's just no. And so, we're not doing 68,000. Sorry, assembly. We're not doing X86. We're doing ARM32 because ARM32 is a joy to work with. Okay, so all of you guys are created. Is there a Raspberry Pi 4 version? It's all the same. It's all the same. Okay, to be fair, there is something we're learning ARM32. 64-bit systems like the Raspberry Pi 4, you can boot the Raspberry 4 in 64-bit mode. There's a different assembly for 64-bit ARM. It's called ARM64, and it is different. So we're doing ARM32 or A32. Sure. Should we get the one you showed on Amazon? They're more or less equivalent. See what the price is. That's honestly the only thing that the A32 ARM assembly language. I mean, honestly, chapter for chapter, they're the same. There's just a couple extra chapters in this one. Oh, it's only $9. Yeah, get this one. Get this one. It's $4 cheaper. All right. So, really good book. Bruce Smith is like, he's like this rugby dude, like who lives in Britain. Like he just looks like a guy that plays rugby. I don't know, but he writes really well. He writes very clearly. He doesn't use a lot of technical jargon. The Raspberry Pi book actually walks you through the basics of Unix and how to compile things and how to use GDB and things like that. And he's very clear, very understandable. So, the Kindle version was $9.99 for the other one. Okay. Okay, there you go. Ooh, you can get this one used for $7. So, knock yourself. Either one will work. I would personally get this one, just because if you do neon programming, these sections are a little bit more developed than in the other book. Okay. Yeah. Okay. So where were we? We're on the server, and if you type cd, we need to push out the homework again. Sudo deploy homework CSCI 45 SM first homework. You already have it. How do you have it already? Did I not delete you? Did I already deploy it? Did it not delete the files? That's troublesome. All right. You made a typo in your password. You can't log in now. Help. Let's do that. All right, Alan, your password is now puppy. McLaughlin. Okay, Alan and McLaughlin, your password's now Puppy. Hmm. Oh. Hmm. Hmm. I don't know. Yeah, close out a putty, and if it locked you out that for typing in the password wrong too many times, then just hang out. I'm gonna lecture for a little while anyway. Okay, so yeah, here we go. So here is the tutorial you guys need to go through. There is a text editor we're going to use called Vim, and Vim is the programmer's text editor of choice. For people who think it's too hard, you should be aware that I taught my daughter how to copy, paste, and edit code in about 10 seconds. So I have a video of my 8-year-old daughter going YYP, I to insert mode, editing the code, hitting escape, YYP. She never programmed before and was doing that. So basically, if you want to edit a file, Vim, and then the file name, and then you're inside of the file. It's a text editor, but unlike normal text editors, you can't just type. You have to type I. I puts you into insert mode. Now you can type things. Type escape, and it puts you back into command mode. Now, this is different from like basically every other text editor out there. And the reason why there is this command mode is because it allows you to do things like YY10P and copy and paste something 10 times. So if you want, you could Control V and do a block selection of text and hit X and delete all of those things from all the different. Like, it's incredibly powerful that a lot of people, when they're doing Visual Studio, they go, okay, forget about it, right? Forget about it. Vim accelerates your coding speed, and the more Vim you know, the faster you will be able to program. What languages are supported on the server? I don't know, like C++ and C and stuff. Fizzbuzz, you suck at coding. Emacs. I don't know if I have Emacs installed. Yeah, Emacs. No. What about Pico? Do I have Pico installed? No. Nano? Same as Pico? No. Use Vim. Jed. Is Jed installed in here? No. Use Vim. Hey, Nick, you answered the front door? Hang on. Somebody's knocking my front door. Let me pause the recording. They're pounding on the front door. Resume recording? Resume recording. Good. Just very overeager UPS deliveryman. It's like pounding on my door. Boom, boom, boom. Did you miss too much? Jumped in late. Did you miss too much? Yeah. So now we're just going through the syllabus and getting people set up on the server. Server is rpi.csci4x.com. So yeah, if you've never used Unix before, if you've never used Vim before, I'm not going to dwell too much on this. Most of you guys are my previous students. A few aren't. So if you're not, just go onto the help channel after class is over. There's a help center on Discord, and I'll pull up Discord. The lecture room here that you guys are talking on is used only during class hours. The help center here, though, is open 24/7. Hello, I'm here for the participation credit. Seriously, Zach. Yeah, look at this guy. Hello. What my participation points? Yeah, but just ask questions on there, and I do office hours every day from 11 to 12. Just message me. I'll meet up with you. UPS doesn't even knock for you anymore. Yeah, the dude was like banging on my door, dude. Like I was like, I felt like my neighbor was like mad at me or something. Like my neighbors don't get mad at me, but like there's been times in the past where like my pipes burst outside my irrigation and it flooded his yard. So he came by and he was like knocking like turn your water off, dude. Okay. So, yeah, I'm not going to dwell too much more on Unix and Vim. This has everything you need to know on it, this slide here, and I can help you as well. It looks scary if you've never used it before. It's not scary. It takes 5 minutes of training. Like I said, my 8-year-old daughter picked it up in 10 seconds. Okay, so agenda, syllabus review. 40% of your grade in this class will be homework. So this is a change from years past. There's going to be a lot of programming in this class, and yeah, so I want people to be able to code assembly. What I found last year was because the programming part of it was only a small percentage, that people were just like not doing it. They're like, I'll just take a B in the class. And I'm like, no, you need to learn assembly. Like, that's the point of this class, right? So there will be code. There will be code. And you don't need to know any programming languages. That's the beautiful thing. I guess you need to know a little bit of C++, but you're going to be learning a brand new computer programming language called ARM32 Assembly. And so you're going to learn from scratch. It's like CSCI 40 all over again, except using assembly instead of C++. So 40% will be homework. You will do weekly programming assignments. 10% will be reading the books, 10% daily participation, 10% daily quizzes, and then each of the major exams are only 10% of your grade. So the midterm 1, midterm 2, and the final, which is going to be on week 6, week 12, week 18, each are going to be 10% of your grade. So it's mostly just programming. All right, so 3 main topics. We are going to rotate through these 3 topics. We are going to do one, then the other, and then the one, then the other, then the other. We're going to rotate with physical computing, unfortunately, getting mostly muted this semester. So we're mostly going to be doing architecture and assembly programming, and we're going to go back and forth. Computer architecture is mostly conceptual. Computer architecture is, how do computers work on the inside? How does the CPU work? What's inside of a CPU? It's mostly conceptual. You're not going to be making a CPU in this class. I made a CPU once. That was a junior level class. So that was CSCI 140 and 141. It was a 2-quarter class where you, across those 20 weeks, you actually make a CPU. Simple CPU. Pretty cool. It's a fun class. I didn't fab it or anything. It was all simulated. Yeah, physical computing is usually my favorite part of this class, and unfortunately, there's a pandemic going on. So I talked to Nico yesterday about how I've got giant stacks of Raspberry Pis in my house here. They're on the landing of my house. There's just boxes everywhere. It's been that way since March of last year, and I'm ready to get rid of them. I talked to Nico about the school picking them up and giving them out, but he said I would need to inventory them all first, and I don't want to do that because it's a lot of work. So we'll need to figure out a thing. I might just do a pickup day or something like that, where you guys can come by, and or maybe a few students can come by and you can distribute them. I don't know. We'll figure that out later. Don't worry about it. But computer architecture is mostly conceptual, so you're just going to learn what's inside of a CPU, and then assembly programming. A lot of assembly programming. It's fun. I like assembly programming. It's fun. Okay, so yeah. So with computer architecture, you're going to learn. When you go to Best Buy, and at Best Buy, it's like this laptop has 64K of L1 CAD. I don't know what it means, So yeah, basically, when you finish this class, you'll kind of understand at a low level what a computer is actually doing. Because right now, this is you, right? Unless you've studied it before, there's just this giant mystery box, and you don't know what the hell's going on, and it just does things, you compile your code and you run it and it runs and it's magic and you don't need to worry about it. And that's true. You normally don't need to worry about it. But if you know how a CPU works, you can write better code. If you know how a CPU works, you can write better code. If you're going to be doing a tic-tac-toe, Pente program, is it faster to go through all the spots on the Pente board horizontally or vertically? Imagine a giant tic-tac-toe board. And it turns out horizontally is faster, and that doesn't make any sense to anybody who has not taken computer architecture, right? So, so ultimately, the CPU is going to go from being a black box, like it's just this mystery device that just you run things and it works, to like, okay, I understand how it works. And if you understand how it works, you can write better code. You can write faster code. You're going to be working with your architecture instead of against it. Okay? That's the thing that plagues JavaScript programmers. They're so far away from the CPU, they have no idea, like, what makes things fast, right? And the language doesn't help with it. It's so far removed from a CPU that, like, you could change something, the performance might drop by half. You have no idea why, right? It's so detached. And so you're probably not going to write assembly code full-time professionally. It's very unusual for people to write assembly code full-time professionally. But when you write assembly code, you come to understand the architecture. And you have to understand what's going on inside of that mystery device there to write good code, to write fast code. What if you store it as column, row, box? We'll talk about that. Totally ready to shame some innocent Best Buy employees. I know, right? Like a couple of years ago when I took this class, or when I taught this class, not took this class, I was like ragging on Best Buy, because I go in there and I'm like looking at the cards they have next to the different laptops. I was buying a new laptop, and I'm like, no, that's wrong. No, that's wrong. That's not a Core i7. That's a Core i5. Like, you can go to your system properties, right? Like go to properties, and like, no, that's not a Core i7. That's a Core i5, dude. Why are you lying to me? And so I come into class and I'm like telling the class how horrible Best Buy is, and one of the students like, I work at Best Buy. That's the mystery device. That's a computer. It's a motorcycle computer. It's a motorcycle. It's got a seat on it. You can sit on your computer. It's a motorcycle computer. You put handlebars on it.
But he said, wait, stop. Don't use Best Buy.
I mean, it's...
What did he say?
How many computer stores are there in town? There's Best Buy. And then there's Best Buy.
What did you say about Best Buy?
They have cards, like when you're buying a laptop, it's like, this has 32 gigs RAM. This is a 1080p screen. And a lot of the 1080p screens are 720p screens. And like, they just straight up, they're either mistakes or they're lies. I don't really care which. And so,
don't use Best Buy in this, and that guy's like, work at Best Buy.
Yeah, the student's like, I work at Best Buy. I'm like, well, sorry, but fix your damn cards, because if I'm buying a laptop because it has a Core i7 processor in it, and it has a Core i5, I will be pissed if I ended up buying that, so just fix the damn card, you know what I mean? So, yeah, I mean, the Fry's in the Bay Area is out of business. I used to get my stuff from there. The original Fry's out of business. So, what are you going to do? Buy a laptop on Amazon, and then you find out you don't like the feel of the keys? Like, I like to be able to hit the keys on a keyboard. I hate the damn chicle keys, like the little rubber keys they have on some laptops. It just feels so... Yeah. I want to, look at a laptop and lift the lid up and see how heavy it is. And membrane keyboards are, horrible. Okay, anyway. Enough about Best Buy. I'm sorry if any of you guys work at Best Buy, but they're terrible. But I mean, what else are you gonna do?
Can you just fix the tags then? Just fix the tags.
I'm not gonna fix it. You want me to go into a store with a pin?
People who work at Best Buy.
They're not here. Okay. All right. So, so if you understand how a computer works, it benefits everybody. It benefits, like, this class is actually really beneficial. Like, whenever I go to CPPCon, which, I haven't, because there was a pandemic, but whenever I go to CPPCon, the World C++ Conference, they use the topics from this class all the time there. Even though we're writing C++, they'll be like, yeah, so the reason why I don't use exceptions is because the interrupt table on the architecture I developed for is really slow, And so there's a cost to throwing a software interrupt. And so like all the topics we learn in this class are just tossed around in casual conversation at a C++ convention, because C++ sits on top of assembly. It's like there's C++, and then C++ becomes assembly. And then the assembly gets run on the CPU. And so you got to know all the different layers. You got to know the assembly layer. You got to know the hardware layer. Okay. Imagine letting everyone in a 5-mile radius know you're typing. Yeah, that's mechanical keyboards for the win, right? Okay, so we're gonna learn a lot of things. The Raspberry Pis, yay! You get free Raspberry Pis, except no. Sorry. You know, we'll try to figure this out. I want you guys to do breadboarding and stuff like that. We just need to figure out the logistics of getting it out to you guys. So anyway, so let's get cracking on assembly, because there is your first homework assignments ready. It is out on the server. So what's assembly? When somebody says, I know how to program in assembly, they're probably lying to you, or maybe they're oversimplifying it. There's no such thing as assembly, right? You can't know assembly. There's no such thing as assembly, okay? There is X86 assembly, there's ARM32 assembly, there's ARM64 assembly, there's Spark, there's Mips, there's Motorola 68K, which is what I learned, Lord. Unfortunately, there's a lot of different assembly languages. Okay? And each one is specific to a family of chips. So every Intel CPU ever made can run X86. Okay. If you use the subset of X86 assembly, the common subset, you could take that assembly code. You could have a text file that does assembly, like maybe to do some sort of mathematical computation, like a Newton's approximation or something like that. And you wrote it in assembly, X86 assembly, like the common subset. You could run that on an old 386 processor. You could run it on a modern Core i9 10th generation. You could run it on an 8088, that was made in 1977 or 78, something like that. That common subset of X86 could run on every single Intel CPU. Maybe not the 4004, which was made for like a calculator in the early 70s. But basically every Intel CPU could run that assembly. However, if you took that to a Raspberry Pi is like, what? Never heard of this X86 business. ARM processors are programmed in a completely different assembly language. And so if you know X86 assembly, it doesn't really help you learning ARM assembly. You just have to learn it, like maybe you're just kind of used to programming assembly. That might help a little, but it's completely different. And so if you take an ARM assembly program and try and run it on the server, my main server, which is X86, the X86 is like, I don't know what you're doing. And that's why C++ and C exist. C exists because people were fed up with having to write code for all the different platforms. And so they're like, it'd be really neat if you could just write it in C. I mean, C wasn't the original. There was many languages before C, but just simplifying. So that's why C exists, because you can just write hello world in C, and then the compiler will convert it from hello world into whatever assembly language you're on. So if you're on CSCI.com, it'll convert it into X86. If you're on the Raspberry Pi, it'll convert it into ARM32. And so you only have to write your program once, and then you can run it on any different CPU that has a compiler. Mips the Rabbit is named after Mips. Yeah, the Nintendo 64 was a Mips processor, and I think the Super Nintendo, was on a MOS. I believe it ran on a Mips processor. Yeah, it's a Mips processor. And so Mips, the Mars rover runs on Mips. What is Mips? It's just a different type of CPU family. And I think ARM has basically destroyed them at this point. Same kind of idea, low power, you know, that kind of stuff. It's still around, but yeah, Mips is probably the most commonly taught assembly language, just because professors all follow each other, and so everybody was teaching Mips for a long time, and so it's very likely that if you were taking this class at another college, you'd learn Mips. What's the difference? Let's take a look. Okay, so here's some C++ code. Hopefully, you guys all understand what this is doing. It makes a variable named x, sets it to 42, creates a variable named y, sets it to 21. If you don't know what this means, drop out now. Right? Hopefully this is not a mystery to any of you guys. So it's making a variable named x, setting it to 42. It's adding the two of them together, and it's returning the value. Returning from main? Returning from main? That's weird. It's really strange. Why are you returning from main? The hell? Have you ever wondered why main returns an int? Right? Ever wondered that? It's because it actually returns this value to the operating system. This is the error code returned, technically. It's what it's used for. And so, if we come over here to the server, vim test.c, wow, that's a lot of stuff. Vim test2.c, damn it, that already exists too. Test. There we go. There we go. Boom. Notice I don't even have to include any header files because there's no input, there's no output. I don't have to include anything. This is just pure C code. C++ code also, either C or C++. It'll actually compile exactly the same in both languages. So if I compile this code, if I want to compile it as a C program, I use GCC. Let's see how big the executable is. So it's 7912. Actually, let me make sure I don't have anything. 7912. Okay. And if I want to compile it as C++, it's G++. So GCC is the C compiler, G++ is the C++ compiler. And if I do that, you can see the C++ is actually a little bit bigger. And there's a reason for that that we'll learn. So it actually makes a bigger executable if you compile it as C++. All right. It'll run exactly the same way, which is it doesn't print anything. Right? There's no couts in here. There's no printf. There's no output. So where do I get that value? If I run it, it returns that value, which is 63, right? It returns that value to the operating system. It returns that value to the operating system. And if you want to see what the error code is, from the previous command in Unix, you echo $? It's a little bit of an obscure arcana that you should actually probably know for this class, because this is the easiest way of printing something is to not print it at all. Just return the value and just echo it later. So what does the backslash mean? The backslash means run the command without an alias. So if I were to do G++ test4.c and okay, didn't make any difference. On the main server, my G++ is aliased to include address sanitizer, undefined behavior sanitizer, use the safe C++ library. It actually dramatically inflates the size of the executable. And so on the Raspberry Pi, I don't think I do that. So yeah. And so basically, if you want to see what error code was returned, you can use that variable there. And so if I were to do it again, you'll notice the error code was 0. Why? Because the last command I ran was ls. Right? Ls succeeded. Yeah. And echo succeeded. And echo succeeded, right? So if I run the code again, you'll see I get 63. Okay. So this is the world's simplest program, really, you know. And so yeah, that's, you know, when would you use that? Well, vim which compile. So this is my compile shell script that does all sorts of super cool stuff. it tries to, it'll pre-check your code, and then if there was an error, then it quits. And then it runs Google's CPP check, and if there was an error, you see that, the $? That's the error code. If there is an error, it quits. Then it runs GCC on your code. If there was an error, then it quits. Okay. So error codes are usually used in shell scripts like that. My Quake server, if my Quake server crashes, it throws an error code, and then I have a shell script, and the shell script runs the server. And when the server quits, it checks to see if there was an error. If there's an error, restarts it. If there was not an error, like I typed quit, it says the error code 0, and then the shell script's like, oh, he intentionally quit, and the shell script quits as well. So $? Is the error code, or the exit code, technically. It doesn't mean error necessarily. Like, it's just a number. It is the error code of the last run program. And so if you run anything else, it goes away. So, yeah. So useful in shell scripting, especially. Okay, so so what does assembly look like? So don't panic. Let me show you guys some assembly. So here is how I would write that program in assembly, right? This is the program, x equals 42, y equals 21, return x plus y. So in assembly, set R2 to 42, set R1 to 21, add R1 plus R2, save the result into R0, and quit. Okay. So, scared? Scared. So what the hell is the R2 thing? Why are there hashtags? Why is there a main with a colon? What the hell is going on here? Well, okay. If I were to compile this and run this, you would see the error code was 63. Same code. It's the exact same code. So what's going on here? Okay. All right. Okay. Numbers in assembly, like they're called literals. A literal is like a hard-coded number. Like this is 42 here is a literal. It's an integer literal. That's the vocabulary term. This is 42 and 21 are both integer literals. They're hard-coded into the code. Literals in assembly have a hashtag. So there, that's the explanation there. What is R2, R1, R0? These things are called registers. So this is the central mechanism in assembly for holding a value. Assembly, there are no variables in assembly. There's no variables in assembly. Your CPU has registers, and a register is a variable. Okay. And so you notice how this thing is not called X, it's not called Y. Your CPU has 16 registers, R0 to R15. That's what you got to play with. Okay. There's no X, there's no Y, there's no Z. There are little circuits that hold a 32-bit value. And so what this code here does, move, puts the value 42 into R2, register 2. This puts the value of 21 into register 1. So that is like x equals 42, y equals 21. But you notice there's no x, there's no y, there's no z. It's just register 0 through register 15. That's what you got to play with. And if you run out of registers, we'll have a lecture on that later. You can write to RAM. So, but basically, everything that takes place in your assembly code will take place in a register. Period. If you want to add things, if you want to subtract things, if you want to multiply things, they take place in registers. And so you can load values into registers with move. But basically, you know, everything is just adding 2 registers, subtracting 2 registers, multiplying 2 registers. Okay. And this part here, global main, that just means that's the start of the function. And BXLR means return from function. And so that's the program. And the return value from a function is put into R0. The return value of the function is in R0. So whatever value just happens to be in R0, when your program ends, you notice there's no return. If you guys have ever done X86 assembly before, I believe there's a return function where you can return a value. In ARM, just whatever is in R0, register 0. At the end of the day, that's the return value. It has to be R0. R0 is the return value. There's something called the AAPC, the ARM Architecture Procedure Call Guide, and it dictates all these rules. And you will learn them from me. You don't have to read the document. What's the file type for assembly code? .s. .s. And we'll show you in a second. So you can compile it using GCC. So GCC test.s will compile this code. And it'll make an a.out, and you can run it, and it'll be exactly the same. So, in fact, let's just do that right now. Damn it. Test 4.s. Okay, good. Global main means it's a function, basically. Main, start of the function, move R0 42, move. By the way, caps don't matter. You're going to hurt my brain if you write code like this. Add R1 BX LR out. This hurts my brain. But that should compile fine. So GCC, test 4.s, run it. And you can see I get 63. So this is SpongeBob. SpongeBob case, right? The alternating uppercase and lowercase. Right? But yeah, caps don't matter at all. They matter for labels. But for all the assembly commands, you can go uppercase, lowercase. Doesn't. So I'm going to fix that, right? Because it bugs me. Did you know that tilde switches the case? Tilde in Vim? Tilde? Did you guys know that? Tilde twiddles the case of a letter. So this is going to put 42 into register 0, puts 21 into register 1. It adds register 0, register 1, and saves the result into register 0. You'll notice the destination register is always on the left-hand side. There's one exception to that in the language. But basically, the destination register, the register that is written to, is always this one. Okay? So this is writing 42 into R0. And, you know, this is basically the same thing as saying, like, x equals 42, right? So if you've done C++, it's the same thing. X is equal to x plus y. It's return save there. So that's the C++ equivalent. Okay. You cannot add two literals. You can only put literals into variables or registers using move. Everything is done in registers in ARM. In Intel, you can do things like there's a command in Intel where you can say like add the value at this memory location to the value at this memory location. You can't do that in ARM. In ARM, you would load from RAM into a register, load from the other address into a register, then you add them. Everything is an int. Is it signed? Is it unsigned? I don't know. So what do you guys, if you guys just had to guess, what do you guys think the command to subtract is? If you just had to guess. What do you think the command to subtract is? Sub, very good. So let's compile that again, run it, and you'll see you get 21. So it is now x is equal to x minus y. Okay. What about multiply? What do you guys think multiply is? So once you've typed it, how do you run it? Okay, so you got your code here. So the workflow is you edit your assembly code. You edit your assembly code, save and quit. You compile it using GCC, and then you run it using a.out. This is your workflow. These three commands, you'll be doing these three commands over and over again, over and over. Unless you use like make to automate your build. Make is very useful. For your homework assignment, you're going to be using make. Okay, then you run it, and then if you want to see what the output is, echo So mul is the multiply command. So what is 42 times 21? What is 42 times 21? Anyone think 114? Definitely not. Definitely not. The reason for that is because Unix actually doesn't get an int, it gets a char. And so Unix only uses the lower 8 bits from the return value. So there's only 255 possible error codes. So it doesn't actually return an int. And C++ lies to you. It says int main. Nope. It's char main. It is actually Charmander. Wait, no. It's returning an 8-bit number. And so if you ever go over 255, it's an unsigned char, I believe. It'll wrap around. But let's just do this. 4 and 2. And you can see, indeed, multiply does the multiply correctly. The multiply does the full 32-bit multiply. Unix crops it to an 8-bit number. Can you show that again? Sure. So I'm putting 4 into register 0. I'm putting 2 into register 1. Again, registers are just hardware versions of variables. It's all there. They're all 32-bit integers. If you want to do floating point numbers, that's later in the semester. There's different registers for that, actually. Yeah. So register 0 gets 4. Register 1 gets 2. I add register 0 plus register 1, save the result into register 0, or multiply these two guys, save the result into that. And there you go. So, so some commands actually can take numeric literals in them. So for example, if you want to add R0, and 1, you can do that. That actually works. plus. That's fine. Some commands can take a number in the third spot instead of a register, but it's not a full 32-bit number. And so this is the better way of doing it. That's the better way of doing it. This number here, it's kind of an 8-bit number. So for small numbers, it's fine, but don't try doing something like that. It won't work. You try compiling that, invalid constant. Yeah, doesn't work. But, 13 would work. Okay. So the better way is just to put numbers into registers like that. But if you need to, you can, small numbers from 0 to 255 work fine. And then it gets more complicated after that. Okay, so x is now 5, y is now 3. We're going to multiply them together. And we get 15. Can it return a negative? It can, but again, Unix just crops it to an unsigned integer. But yeah, it handles negative numbers fine. They're all technically signed or unsigned, depending on if you want them to be. Multiply, though, cannot take a number. This does not work. Can't do that. Try compiling it. It'll say register was expected. So for multiply only takes registers. Common mistake students make. Okay, what do you guys think the divide command is? How do you convert to different types? We'll learn about that later. For now, just everything's in it. There is no divide. Trick question. What about modulus? Do you think there's modulus if there's no divide? Nope. There's no mod, there's no divide. Bad instruction. There's no divide. There's no divide, there's no modulus. There's add, subtract, and multiply. Yep, that's it. Add, subtract, multiply. That's it. That's all you got. That's all you got to work with. And that's all you need to know for your homework assignment. So your homework assignment is algebra. Okay. So let's I want to show you the homework, but let me just show you. This is, do you guys all understand this now? Does this make sense? You're putting 42 into X and 21 to Y. And notice which is X and Y is just sort of like, whatever you call it. Yeah. All right. Bridges algebra. Here we go. Here we go. Here's what GCC. So GCC, your compiler, generates assembly. You don't see it, but this is the assembly that gets generated. And you can see this is my program, and this is what GCC makes. Okay? So my program, what GCC makes. Okay? If you turn on the optimizer, that's what GCC makes. Do you guys understand what's happening here? Do you understand what the optimizer did? It's like, there's no reason to add those two numbers. I know what the result is. It's 63. So, yeah. Dash 03 dash capital 03 is the optimizer. If you want your code to run fast, look at the difference. Look at the difference. The performance is going to be probably about 2,000 times faster, something like that. Doesn't look 2,000 times faster, but it probably will be. Okay, so GCC cheated though. Like I wanted to show it how to add, and it's like, no, I know what the answer is. So if you want to see what X86 assembly looks like, this is X86 assembly. This is how you do it on the other server on a PC. This is what X86 assembly looks like. We shall not discuss it again. In general, though, EAX is like register 0. There's B, there's C, there's D. There's the stack pointer. X86 has 4 registers to play with. In ARM, you have kind of 8. It's technically 16, but there's really 8 that you use. 68K, which is what I learned on, it looks like this. Move 42 into D0, move 21 into D1, add them, turn. And then, did I have any others in here? I guess not. Okay. So registers are named R0 to R15. Basically, the registers you want to use are R4 to R11. Just for general purpose stuff. So some of the registers are special. So don't ever use register 13, register 13, register 14, register 15. Don't ever read from them. Don't ever write to them. They're used for things like, what's the next line of code that's going to run? That's register 15. What's the next line of code that's going to run? If you put a 0 in there, if you use it as an integer, your code's going to jump to some random spot in RAM and start running it. It's a really bad idea. The best way of killing your program is write to register 15. Register 14 is the return address from your function. Again, if you change that, then it'll return to some random address in RAM and it will explode. Your code will crash. Register 13 is the stack pointer, if you remember that from C++, that keeps track of where you are in memory. Don't mess with that either. Right? So don't ever mess with 13, 14, and 15. Except when I tell you to, I guess. On the other side of the spectrum, registers 0 through 3 are used for passing parameters to a function. So the first parameter, so like in C++, when you call a function that has 4 parameters, the first parameter, like 4 ints. Let's make it simple. If you're calling a function that has 4 integer parameters, the first parameter goes into R0, the second parameter goes into R1, R2, R3. And then the return value is in R0. So that's how functions work. And so for your homework assignment, you're going to just do algebra. You're going to get some parameters. If you have more than 4 parameters, that's a later lecture. think my daughter just seg-faulted. Okay. Yeah, register 0 is the return value. Register 0, 1, 2, and 3 are the parameters passed it. And so, for example, for the homework assignment, you're going to get 4 parameters, and you have to do x times y minus z, something like that. And so you're just going to do adds and subtracts, and that's the homework. Okay. So yeah. So BXLR means return from function. This is the start of a function. So global main and main means there's a function named main. And then at the bottom of it, you return. Okay. So for your homework assignment, it's become, yeah. Did it not work? I deleted did it not delete people? Oh, you stayed logged in. Yeah, well, it's your own damn fault. Just copy over your .cchgrc file. Yeah, if you guys didn't log out, Trangio hasn't logged in either. All right, well, just edit your .cchgrc file. So vim.cchgrc, and then at the very bottom, there is a line that says set common host. Just delete that line. And delete that line. So any line that has the $ IP in it, delete those. And you're good to go.
I have a floating head.
Yeah.
Does this look like I have a floating head?
It totally does, bro. And you can disable this line as well. Okay, anyhow, you guys should have logged out. You didn't. It's your own damn fault. Okay. So let's go into the homework. And there we go. Here's homework assignment. How do you pass in parameters? Don't worry about it. So for this homework assignment, there is a main.cc that you will not touch. So main.cc is going to call foo, it's going to call bar, it's going to call baz, and it's going to call cuz. And so these are the functions you are going to write. You're going to write these functions. Okay. You don't have to modify the C++ code at all. You can look at it if you want. This is the whole code. Okay. And so all it's going to do, it's going to read in a value for x, y, z, and w. The user is going to pick which function it wants to call, and then it calls that function and prints the result. Okay. So it's a very simple driver that will drive your assembly code. Okay. So, yeah, I don't know. The delete, the purge didn't work, I think, because people are still logged in. Okay. So let's take a look. So foobar, let's open that up. So you can see there's 2 functions inside of here. So this means there's a function named foo. This means there's a function named bar. The parameters will be passed in R0, R1, R2, R3. And so for foo, you have to write a program that returns 4 times the input value. We can do this one together if you want. So you cannot pass in 5 parameters. That's a later lecture. You have to write it to RAM. And we're not going to worry about that right now. 4 parameters is enough for now. So how do we return 4 times x? And x means register 0. So register 0, I'm calling x. Register 1, I'm calling y. Register 2, I'm calling z. And register 3, I'm calling w. So how do we return 4 times x? That's the code in C++. That's the code in C++. We want to write it in assembly. Can you write a value to register in one function, then access that value in another through that register? Yeah, they don't change from a function call, but we'll learn about that later. So for this, all you should be doing is reading from register 0, multiplying it by 4, and then you don't have to return anything because it's in register 0. So how do we multiply it by 4? Remember, you cannot, you can't do this. This does not work. Mul R0, R04 does not work. Yeah. So you have to move, as Mr. Media says, move 4 into register 1 and multiply that. And that's it. That's the first of the 4 functions. Yeah. Whatever value is in register 0, when you return, this is the return command, is the return value. And so if we compile it, type make to compile, run it, and if we run foo is option 1, you see we get 4. So it's correct. We can run it again, and we see that 8 times 4 is 32. Okay. So it starts simple, it gets a little bit more complicated. 2 of the functions are in foobar. I do this to show you guys you don't have to split one function per .s file. So bar, you're going to multiply x times y and subtract y times y. So figure out how to do that. Add, subtract, mul, that's all you need. For Baz, you're going to be returning 5 times x plus 5 times xy plus 5 times xyz. When is this due? It'll be due in a week. It'll be due start of class next Tuesday. Do registers have a default value? Nope. They will have whatever value was in them from the function that called them. So whoever called you, the values are going to be a certain state, and they're just going to have values. So, yeah. For this assignment, I would just use R0 through R4, honestly. And then the most R0 through R3. And then the last one is more complicated. Yep. So it starts easy and gets hard, and all you need is add, subtract, and multiply. Yep. That's it. So you got a week to do it. It's not bad. We're out of time, but one final note. There is Code Golf. Code Golf. The top 25 students in this class, 25% of students in this class will get plus 25% added to their grade. So instead of 10 points, you will get 12.5 points if you pass all the test cases. There is something called an input tester. Input tester will tell you your score on the homework assignment. Does not exist. Oh, it's all right. Give you guys permissions on it. Okay, so this is the input tester. So you see that Shammy is now passing the test case, probably corresponding to the first function, and he's passing this one, he's passing this one. Well done, Shammy, you're passing. So Shammy, if the homework was graded today, he would get 3 out of 10. Of the people who get 10 out of 10, the people who have done the homework assignment, the people that code golf at the best will get 25% extra credit added to their score. And so the README, you cannot use the optimizer. You cannot use the compiler to generate assembly for you. That is cheating. You have to write this yourself. It's also usually obvious when students use the optimizer. So, so the code golf is this. Every add, subtract, and move is 1 stroke. Every multiply is 4 strokes. Okay. So whoever has the minimal number of strokes gets extra credit. Top quarter of the class gets 25% extra credit. And I've put down how many strokes mine is on here somewhere. Mul is 4 cycles, yeah. complicated, but yeah, let's say it's 4 cycles. Mul takes between 1 and 4 cycles, depending on how many bits you have in the number. Multiplying an 8-bit number is 1 cycle, 16-bit number is 2 cycles, and a 32-bit multiply is 4 cycles. Since we're doing 32-bit numbers here, it's 4 cycles, worst case. But it actually depends how many bits are in the number, or in the register. Yep. So the label doesn't cost you anything. The BXLR we're not counting either. Those are no strokes. Add, subtract, move is 1. Multiply is 4. If you call a function, that's 40 strokes. And I have a little hint here for a way that you can save on some strokes. You can call a function if you want, but I wouldn't recommend it. Does it go by how many bits are set to 1 for a bit field? Yeah. So wherever the most significant bit is that's set to 1, that controls how many cycles the multiply is. But for simplicity's sake, we're just going to say multiply is 4 strokes, because I could type in a 32-bit number, right? So these are ints. So multiply is 4 strokes. Yep. And so my par, I did all 4 of these in a total of 24 strokes. So that's par for the course. So get it correct first, and then after you get it correct, try and cut down the number of needless instructions. Okay, questions? These slides aren't on the canvas. I'll put them up on Canvas. I was editing this late last night. I wanted to have something fun for you guys to do to start off the semester. A little competition, a little compy comp. Get your competitive and creative juices flowing. You don't understand how you use function variables. So okay, so the C++ code is here, Hazelton, right? And it's going to call cuz passing in x, y, z, and w, right? So whatever variable is passed in first is in R0. Register 0 is the first parameter. Y is R1, Z is R2, and W is R3.
Ask the teacher question. Can you text?
Go for it. Okay. Bless you. And turn off your alarm. Yep. So if you're wondering what that means it's a C function. So assembly is basically C. C++ is a little different. And so if C++ is going to call a function in C, use extern C. This little line of code here tells C++ that these are C functions instead of C++ functions. Okay. So there are conditionals. You don't need to know them. This is pure algebra. This is week 1 CSCI 40. How do you make a variable? How do you do algebra? So send an email to her.
Because she's not even on there. There. Okay. Thank you. Thank you.
Okay. So this is the glue. This is the glue between the C++ and the assembly. And to C++, it thinks that your assembly code returns an int and takes these ints as parameters. Your assembly goes, haha, what is types? What are... Hey, if you used cuz and you didn't use register 3 at all, like C++ doesn't know. There is no type checking in assembly, right? You just have to hope the person is doing everything right. You're scared? You want to rewatch a lecture where the class isn't popping up in the canvas? I will post the lecture on YouTube, and I'll put the link on here. Canvas refreshes at night, by the way. You are unable to log in on the server. Okay. I'll get you sorted out in a second. So, yeah. So Basically, this code, the C++ code, just reads 4 values, reads which function you want to do, it calls the function. This is an assembly function, and then C++ is responsible for printing the result. So all your code has to do is read from registers 0 through 3, do the algebra, and return the result into register 0. Whatever value is in register 0 at the end is returned. Seeing your password is hello. So that's your username. Your password is now hello. Change your password when you log in, because this is going to go up on YouTube. So if you guys don't know how to, those of you whose passwords are puppy or hello, you change your password by that command right there. Type that or you're going to get hacked. Okay. So password is how you change your password. Okay. Is it replaced with all the basic Unix commands? Yes. It's on the PowerPoint slide. Yeah, that's how you compile the code. That's how you run it. And then go through the Unix tutorial here. Like, trust me, let's do the Unix tutorial. It's pinned. I pinned it on the channel here, and then the main commands, main Unix commands. I'll just make a thing right now. CD change directory, ls to list files and folders. Make, compile for homework. Get it out and your program. There. And that's been pinned as well. IS58 is complaining. Why, it starts at 2:30, right? What is IS58 complaining about? Two. Well, okay. My schedule says 2:30, but okay. All right, get out of here, guys. And then we'll make room for IS50. If you have any questions, just message me on Discord, and we'll pick this up on Thursday. Peace. I'll upload this to Discord to Canvas right now.